Okay, so these proofs are going to be a little bit more difficult because we have to figure out the order of the vertices of the second triangle. So let's get started. They're pretty similar to the other proofs though. We're just proving triangles congruent. I have angle B and angle E congruent to one another. I'm also given that BC is congruent to or CE. So that's my given. I state that first. So on each of these triangles, I have two pairs of corresponding things congruent. My first pair is angle B and angle E. So I'm going to highlight that. My second pair is side BC and side CE. So I just need to prove one more thing congruent on each of these triangles, which if we look at both of the triangles, they both have a pair of vertical angles. And by the vertical angles theorem, we can state that those two angles are congruent. We do need to be specific with this. We can't just say angle C is congruent to angle C. The reasoning is because there's four angle C's. There's an angle C here, there's an angle C here, here, and here. We need to be specific. So we need to say angle BCA and angle ECH. Now the reason why we didn't need to do that for angle B and angle E is because there was only one angle B and one angle E. So just keep that in mind. And then that's the vertical angles theorem. You can see how I abbreviated that. But now I have another pair of things congruent on both of these triangles. So now I have three things congruent here. So now I can state that the triangles are congruent. Now let's figure out the order that the vertices would go in. Angle A on my first triangle is going to be congruent to angle H on my second. So those need to be in the same position. Angle B on my first triangle is congruent to angle E. And angle C is congruent to angle C. So triangle HEC should go in the last step. This is by ASA because the side is in between the two angles. All right, number 26 on this video, there's a couple of typos, but it's fixed on your note packet. AB is congruent to CD. That's not a typo. That is given to you. And then I also, the next two are typos. So this should say AD is perpendicular to BD. So that means that this is a right angle here. And it should say BD is perpendicular to BC. Okay, let's get started. So we're going to state our given in the first in the first step. And you see that we have proved one pair of things congruent here. So that's it. We need to continue to prove things from here. Well, if we look at these two triangles, they both share a side in common, and that is side BD. So I can say side BD is congruent to itself by the reflexive property. So that's another set of things that are congruent. Now let's look at this. We know that we're dealing with right triangles because we have right angles. On both of these right triangles, I have leg BD congruent to each other, and I have the hypotenuses congruent to each other. So for this one, I do not need three things congruent to each other. I just need these two because I'm going to use HL. But in order to use HL, we do need to specify that we're working with right triangles because HL only works with right triangles. So knowing that these lines are perpendicular to one another, I know that angle ADB and angle DBC are right angles. That's the definition of perpendicular lines. And you can see how I abbreviated that. Well, if I know that these are right angles, then I know that these are right triangles because the definition of a right triangle is that it's a triangle with one right angle. So triangle ADB and triangle CBD are right triangles. That's the definition of right triangles. So you can abbreviate right as RT. I'm okay with that. I didn't up here, but you can abbreviate that as RT. Now that I know that these are right triangles and I have proved that one of the legs are congruent to each other and the hypotenuses are congruent to each other, I can now say that these two triangles are congruent by HL. But let's look at the order of the vertices. So angle A on my first triangle would be congruent to angle C on my second. Angle B is the non-right angle on my first triangle, so that's congruent to angle D on my second. And angle D is the right angle on my first triangle, which is B on my second triangle. So CDB would be the correct way to write these triangles. So triangle ABD is congruent to triangle CDB by HL. Now, I am going to make it clear to you guys that just because we're dealing with right triangles does not necessarily mean that we are going to use HL. In this situation, yes, we did use HL. However, there are situations where we wouldn't use HL. For example, if I had these two right triangles, I know that they don't look congruent. Let's just pretend that they are, okay? And I said that this side's congruent to this side and this side's congruent to this side. In this situation, we would not use HL because we don't have the hypotenuses congruent. So it wouldn't make sense to use HL because I don't have a pair of hypotenuses congruent. Instead, I have two pairs of legs congruent. So in this situation, I would use SAS because by the right angle congruence theorem, these two angles would be congruent, and so then we can use SAS to prove these two triangles congruent. So there's times where you don't use HL. This would be a situation where you don't. The only time you will use HL is if we are dealing with the hypotenuses and the legs on a right triangle. All right, moving on to our last one. I am given that DB is perpendicular to AC. So that means these are right angles here. So I know I'm dealing with right triangles. Let's see if we're going to use HL or not. Now, this is a typo. This shouldn't say AD is parallel to DC. It should say AD is congruent to DC, which it is fixed on your notes, but let's mark that. Okay, I do have the hypotenuses congruent on these two triangles, so it looks like we will possibly be using HL. So this is my given. I proved one pair of sides congruent already. That's this. AD is congruent to DC. And then now, looking at this, I can see that they share a side in common, BD. So by the reflexive property, DB is congruent to DB. That's a second pair of things that I proved congruent to one another. Now I have a pair of hypotenuses and a pair of legs congruent on these triangles, so we will be using HL. But again, in order to use HL, you need to state that these are right triangles. So just knowing that line DB is perpendicular to AC, we can then say that angle ABD and angle CBD are right angles. That's the definition of perpendicular lines. Now, if we know that these are right angles, then we know that these are right triangles by the definition of right triangles. Now that we know that they're right triangles, and we know that a pair of legs are congruent and a pair of hypotenuses are congruent, we can say that the triangles are congruent by HL. But we need to put them in the correct order. Angle A on my first triangle would be congruent to angle C on my second. Angle B on my first triangle is the right angle. Angle B on my second is also the right angle. And angle D on my first then would be congruent to angle D on my second. So triangle ABD is congruent to triangle CBD by HL. All right, a reminder, we're not always going to use HL when we're dealing with right triangles. Keep that in mind. All right, that brings us to the end of level 3. And level 4, we're doing more proofs.